Normal C. -1, E99, comma. Everyone, I'm gonna hit this, are you okay? I just hit second, -7 gives me ants. That produces what right there? The last answer, that way it's not rounded, isn't that cool? Plus I didn't feel like typing it. Comma, 0, comma 1. Ants, to get answer when I just hit second, negative on a calculator. Alright, what's the p-value?
65%.
See, things in this world happen with 65% chance all the time. Yeah, we can't reject it all. That's what this whole problem is based on. Oh, it's a 65% p-value.
Is this the same case on the sample mean? When you do two-tail, you have to multiply by 2?
Yep.
Okay.
If you do it the way you and I are, if we did it without looking at those cool fast test buttons, we're like, everyone, even with the two-tail test, with the population mean, we'd have to multiply by 2. And you can hear me, let me bang on my head. What did I do right before my test when I took stats? I mean, I was like, do not forget. You could easily just forget to multiply the 2, right? You're in the midst of a test and you forgot, oh, I gotta multiply this by 2. So that arc goes for all hypothesis tests. Because it's two-tailed, right? Makes it harder, right? When that odds, those 65%, you follow me, right? Things in the world happen with 65% chance. That's not rare, that's not unusual. That's not unusual, you stay put. Status quo remains. We retain it. We retain it. You know, it's not unusual for this to happen, you follow me? Given that's the given status quo. That's our interpretation of p-value. I'm going to put words to this, right? We're saying it's not unusual to get results like this if that's the population proportion. That's what we're talking about. That's my interpretation of this p-value. So I'm going to interpret this. I got enough room right here. Interpret this p-value. This is the probability of getting the results of obtaining these statistical results. I say these, the ones I just wrote. These statistical results. You can even put parentheses or more extreme. You know why? Because every time we're talking about we're not just talking about this number, but we're shading what? Beyond. See how we're talking about from that number over? From this number over. Or this number over. We're really, if you want to know where we're shading in the curve, it's from here to that way, and then from here this way. It's more than, and when it's more than 50% of this curve shade, 65%. That's what's getting shaded here. It's like from that number shaded over, plus from this location, reflecting it. Oh, all right, but this is the probability of getting these statistical results, or obtaining these statistical results from more extreme, and then I say, given what? Based on, what's the status quo? Given that rho equals 0.58. It's based on that. Given that that's true.
So we don't have to write really, truly?
We can, I do it for emphasis if you want, everyone. I'm glad I remembered that from last class. Or more extreme, given that this is really, truly 58%, right? Because we're challenging this, aren't we? Is it really, truly 58%? That's why I felt like that. But everyone, these results is the probability of getting this. Well, everyone, do things in this world happen with 65%?
Yep.
Yeah, so my next statement is, because, I got a room right here, because my p-value is lower than the, or excuse me, greater than the
Alpha level.
alpha level, comma, we reject an null, or we do not reject a null?
We do not.
We do not reject H naught, or ho. You could call it ho, right? If your p-value is low, reject the ho. Your p-value is low, reject the ho. Well, my p-value is not low. I do not reject ho. Just phrases like that help us remember that. If my p-value is low, I reject the ho. Well, it's not low. It's kind of high. This is a 0.65, this is a 0.10. 65% is higher than 10%. If you want to write them there, look at that. I want to keep my conclusion here though. This right here was my conclusion. We knew this well before. This always complements what we got over here with the classical approach. When we saw that this wasn't in there, we knew we were doing this, right? But we just want to talk about that. Cool? So it's always good to do both.
Can I ask you a question?
Sure.
Like you said, confidence level, like if you do like 95 times, you told us like, what does the level of significance, like what is that? What does this imply?
I got you. So that level of significance, and when they call this right here, where is it? The 10%. The alpha level. They call this the level of significance. And they go, what is that? What's this 10%? What is level of significance? Before they started this problem, whoever it was a sociologist, right? A sociologist, and maybe the sociologist worked with a group of people. They decided anything under 10% they would consider unusual for their two-tailed test. They came up with that before they started the what? The problem. They went out and did their little what? The random sample. They just determined, hey, anything under 10% we're going to consider as what? Just being unusual. And we're going to go get these results. We're going to go get a sample. But we're going to find out in the end, if we get a p-value that's lower than a 10% value, we're thinking that as, ooh, that's unusual. That's so unusual, something must be wrong with this. Does that make sense? That's what that level of significance is. It's something based off, someone determined, well, anything on there is so unusual for something like that to happen, given some status quo was given. And sometimes you can get p-values really low. And that's indicating we did everything right, didn't have any bias, didn't have any lurking variables, then something's wrong with this, right? It's neat because they can use this in a court of law. Sometimes the challenges say, well, here's the odds of being able to get this. You know, chances are like 1 in a million, so something's wrong with, you know, what the defendant is stating. Stuff like that. Isn't that cool? Hey, super job. There's one other thing you might do. I once had a student, everyone, I like to talk about it now. This student, they weren't really getting it, you know, they're kind of, I'm getting it. And I said, how are you with confidence intervals? Which was chapter 9. And she goes, oh, I'm fine there. I've got confidence intervals down. She goes, check. I go, well, why don't we do a confidence interval on this? She goes, really? I go, let's just look at it. So right now, I'm just going to do a confidence level. Excuse me, a confidence intervals, chapter 9, plus it's good for review. With confidence intervals, we had the shade from the middle. Does anybody have an idea what kind of confidence interval I should set up? Because it'd be shaded from here to here.
90%?
Yeah, now how'd you get 90%? Because it would be 100% minus the what?
10%.
10%. So right now, just for the student, what I did, I was like, well, let's just look at a 90% confidence interval. And what's so cool is with your calculator, well-designed calculator, when I go to the confidence interval button, all my data that I just typed in stays, if I just did this. So watch this. The last place I was at, I'm going to go to stat, and I'm going to use a fast way to do this. Where was the confidence interval?
I think it was number 8
It
or...
wasn't t-test, or it wasn't a t interval
Number 8.
because that was for means. I had to do
Oh, A.
one prop z interval. It was letter A. It's called a one proportion z interval. So well, let's just look at this. So I'm going to type this in. What was X? 285. Sample size.
500.
But the confidence level here was,
0.9.
we're doing 0.9 because 5%. And the reason I wanted to show this to you, because the student, they were a little confused. When they saw this, everything made sense. And they hit this and they go, oh, I get this, because they made a sentence out of this. They go, I am 90% confident that the population proportion has to lie in here. Well, does that lie in there? Yeah, then how can you go against it? And they go, oh, I get it now. I get it now. So did everyone see this? They were a little confused before them, and they're like, now I'm understanding. Remember our interpretation of this? I am 90% confident that the population proportion has to be between 53.3% and 60.6%. Look at the status quo. That's in there. I can't go against it then. It's inside that. And I'm 90% confident? I'm 90% confident it's between there, and there it is sitting there. So I can't go again. I can't reject it. It has to stay. We retain it. You go, oh, I get it now. So sometimes it's nice to just go back and look at a concept. Or you can even report it. It's not a bad idea just to talk about that, right? and your justification. All right, hey, now the fun part, right? Right, Autumn is the fun part. She's been waiting for this. Everyone, when it comes to all this stuff, some of you may not do so much writing. I mean, we'll put the words down, but you see this right here? You might just do what? Can I erase unless someone wants to snap a picture? I know we got it on video, but anyone on camera shot this stuff? No? All right, what? You might just go, I'm going to get this with technology, right? And, see that? See the normal CDF stuff? Ooh, that 2 that I might forget, the 2 times? I'm going to let the technology give me that p-value, right? And then you can make your statement. Isn't that cool? So you could really save a lot of time with this. You'll do your checks and everything. I do want to point out there's one thing the calculator doesn't do. Everyone look at the yellow. The calculator didn't do the critical reason, right? I got this shaded from that number right there, and you can use your t-table to look up whatever the they call them the critical z-scores. You can use this, or you can use inverse norm, but that's the only thing it won't show, okay? But boy, it's going to give me 2 really important numbers. This number, and this is the most important number. And when the minute you see this number, don't you agree? If your p-value is low, what are you doing?
You reject the whole.
Yeah, reject out. So you know already. So this is why it's very important. I highly encourage you to look at this. I'm going to go here. We got to find it though. Everyone, is this a confidence interval or a hypothesis test?
Hypothesis.
So when we go to stat, let me clear this out. Stat. Go to test. Look for a 1 prop z test. 1 prop z test. Not just z tests. So I want to point out everyone, don't do number 1. We'll never hit number 1. No. Never number 1. Where's 1 prop z test? 5. Hey, Thursday we'll just kind of review everything. Just summarize. Where are these cool buttons? Write them on the board. All right, what was the status quo?
0.58.
Boom. Oh yeah, this is the same number. Oh, and you got to highlight and enter which one. They're not equal to, right? I don't like draw, I just like calculate. There they are. And you go fill them in. And the minute you see this, this tells you what's going on. This tells you everything. P-value, 65%. That's higher than 10%. There is not evidence. Right? Negative 0.453. It's over there. You're like, oh my God. So when I'm going to erase the majority of the board, I'm going to pick a problem out of this textbook, and I want who's got their calculators with them? Let's use it. Let's use this button. Let's go to it. And let's look at that p-value. We'll do everything. We'll write everything down. We'll make a nice picture. I just think it's going to take us 1/5 of the time it took me to do all that. Do you follow me on? What they realized over the years, a lot of students made some errors. The really good students too. Everyone, right? Made little errors in this 2 times all that stuff. Reading this stuff. So we're going to let this facilitate it. What we're trying to do is, we want to be able to interpret this stuff. That's what's most important. All right, let me find a good one. Everyone, number 24, titled Infidelity, from menstuff.org. That's the 20. They said 22% of married men have strayed at least once during their lives. I can tell. I see the wording. They say is different today. That's a 2-tell test. I'll let you all pick. Do you want that one, or do you want the one about the death penalty? It's number 32. Where'd they get this? They said the status quo was 65% in the first sentence. Someone went out and did a sample, and someone made a headlines. You want to do the death penalty one? All right, let's do that one. That one, everyone, by the way, is not 2-tailed. Everyone okay with the 2-tailed test, do you think? Mm-hmm. All right. Hey, then let's definitely do number 32 from the textbook. It's about the death penalty. But I think when we're reviewing on Thursday, someone will remind me, Tia, you remind me, let's do another 2-tailed test, because sometimes we can forget about taking this and doing what? Oh, yeah. Slicing it into 2, right? Cool. I just want to be careful of that. We draw for evidence. Alright, so, I'll leave the conclusion box open. I'll leave this blank. This is the probability of obtaining these statistical results or more extreme. Given that, we'll see what we have for the status quo. We don't know what's going on with p-value and alpha. I'll erase that. And we'll see whether or not we're going to reject the null hypothesis. I can take that out. We'll fill this in. And let me erase this. We're going to make another bill. Don't know what I'm doing there. Take off my check mark. See what the alpha level's given. So I don't know if it's a two-tailed test. They're going to give us some p hat. I'll record, and I'll get this out of the way. But this will be proportions again. And by the way, feel free to look at the confidence interval when you're done. All right. Now, and this is kind of interesting because this is a true story. And this was done in November 2009. 6.5 years ago, right? About 6.5 years ago. Little over 6 years ago. 65% of Americans favored the death penalty for a person convicted of murder. All right. Well, there's the status quo, right? First sentence? Rho equals what?
0.65.
This is always an equal sign. Now, I'm going to keep reading. Well, in November 2010, a year later, sample was done. Someone took a sample. 1,025 adult Americans were asked by the Gallup organization, are you in favor of the death penalty for a person convicted of murder? And of the 1,025 adults surveyed, 653 responded yes. So I'll put those numbers on the board. I want to see what they're thinking here. Someone wrote an article right after this, right after the survey, and this was the title of the article. The headline of the article was, fewer Americans favor the death penalty. Someone put that as their title and wrote about this, because it was based on this one. This article. That's a powerful statement, right?